And hi, I'm Karan from the Pegasus team, and welcome to our first ever online Pegasus office hours. Uh, we are starting out this series on every 2 months basis, and the purpose of this online office hours series is for to give an opportunity for our users to connect with the Pegasus development team at ISI, and also to drill down on some new features that we've introduced or are planning to introduce, and give an overview of those specific features. So for our first ever office hours, we are going to focus on the container support in Pegasus that we introduced in Pegasus 4.8.0, which was released in September 2017. I just wanted to make sure that everybody can hear me fine, and we want this session to be interactive. So if feel free to jump in and ask questions where things are not clear. And uh, right. So what are containers? They are lightweight and they're a lightweight and a reproducible way to run application on heterogeneous nodes. Containers allow users to separate their user application from the node OS where the application runs. Right now, we have two popular container technologies. One is Docker, which is more popular in the enterprise world. By default, an application launched in container runs as root, which can be a concern when running on shared infrastructure like your campus cluster, OSG, or Xceed. Then we have Singularity, which is popular in HPC environments, which has been developed to address the concerns of a user application running on a shared resource as root. By the only way to run your application in Singularity is to run it in user space. So why do we want to use containers for your workflows, or specifically for Pegasus workflows? So for that, let's look into what's the traditional way of referring user executables in Pegasus. So as people may know, jobs in the input abstract workflow refer to logical transformations. The reason why we do that is because the input description where you describe your workflows is a portable description. And then users define a mapping of this logical transformation to an actual executable in a transformation catalog. Out here, I have a snippet of a simple transformation catalog where there is a ls command that exists on a compute site. It's our standard bin ls command. So how do we describe that? ls is a logical transformation. So in your DAGs, you refer that a job uses the ls transformation. And then we give the executable description where we list the locations of executables per site. So here we are saying that ls transformation exists on site, compute site. The PFN stands for the physical file name and gives the path where ls is installed. Type indicates whether it's installed or stageable. Pegasus has a notion of staging executables to remote sites. Architecture tells what the compute site architecture is for which this executable is compatible with. And then we have OS versions, like you specify what OS this executable is for. There are optional attributes, OS release and OS version, like CentOS and 7 in this case. In case of executable staging, it works if an executable is statically linked or libraries are already installed on the nodes for dynamically linked executables. So Pegasus has this ability that it can take your executable and ship it along with your input data uh, to the node where the job runs, and then the job will refer to the executable that is staged. Uh, to to make sure that the right executable gets staged to a remote site, Pegasus will match the attributes of an executable defined in the transformation catalog, which I just showed you, against the attributes specified for a site in the site catalog. As a reference, like site catalog allows you to describe what sites you want to run your workflow on, and there also you specify an OS and architecture, OS release for the nodes making up that particular site. Uh, as you can imagine, this approach works fine if your site is made of homogeneous nodes. So let's say like you're running, which is true for most of the traditional HPC cluster sites, that the nodes will be running a standard version of Linux, which is homogeneous across all the nodes. However, problems do occur when you run on a site with heterogeneous nodes, or your job lands on a node where the OS is incompatible with your executable. One of the examples would be, if you look at a distributed infrastructure like OSG, where you don't have too much control over what node your job is going to land on, and they're scavenging resources from various campus clusters, then chances of this occurring are higher. Another reason could be that application is a mismatch to the compute node environment. So what do we mean by that? For example, your application requires libraries that you need to install in a shared space, and you have to make sure that environment refers to those libraries. For that, you need cooperation from site admins. For example, on OSG, you can install things in CVFMS, FS, which is a way of distributing executables across all the nodes in OSG. Another example would be like TensorFlow. So TensorFlow requires specific Python libraries and versions. Some libraries may be easy to be installed on latest Ubuntu, but not on EL7, for example. So these application dependencies sometimes can become hard to manage in a traditional HPC environment where you don't have control over the resources itself. So you are running on a shared resource, and you don't have an option to do a pip install or do an RPM install on the remote nodes. So for these particular scenarios, it makes containers are a good solution, because containers will allow you to package your application and all the associated dependencies in a container file. Considering this, we introduced support for containers in Pegasus release 4.8. That was the last major release which we did about 5 months back. And we have support for both Docker and Singularity containers. So we leave it up to the users of what container technology they want to refer to or use for their workflows. Users now can refer to containers in Transformation Catalog with their executables pre-installed. So you can tell Pegasus that I have an application container which has all my executables pre-installed, and use that container for running the workflows. Or users can also refer to a container that they want to use, and however let Pegasus stage their executable to the node. So this is useful if you want to use a site recommended or a standard container image, and then deploy your executables into the container as your workflow runs. This use case is useful when you're developing your application code. And you can use this in conjunction with executable staging. So how do we specify containers in Transformation Catalog? So to do that, we've extended the Transformation Catalog. So here is a Pegasus Keg installation on a site ISI, where the PFN refers to what is Pegasus Keg. It tells us what the OS is, version, release. And then we have an optional container attribute, which you can use to refer to a container that you also define in the transformation catalog. So here we are saying that we're going to run on a container named CentOS Pegasus. Now, the container itself then gets defined as a separate element in the transformation catalog. And essentially, you have to specify two required attributes. One is type, what type of container it is, whether it's Docker or Singularity. And then there is a image attribute where you can specify where does your container image reside. For example, if your container image resides in Docker Hub, you can specify this using the Docker URL naming scheme. And similarly, you can also point to images in a Singularity Hub. The other option which you have is that you can also have your container images exported as tar files and give URLs for that. So you can have an existing Docker image exported as a tar file and place it on your local submit host, and Pegasus can use that container image too. So it's not required that all containers that you want to use need to be published to a hub. It's up to you. So what does the type attribute for your executable means in case when you're running in a container? So if your type is installed, then Pegasus takes it to mean that the PFN refers to the path in the container. So here, what it's telling me is that user bin Pegasus keg is installed at the location user bin Pegasus keg in the container. CentOS Pegasus. Stageable means that the executable can be staged into the container. So in that case, that could have been site local with stageable, and then we'll take this executable from that site and place it into the container when we run. Any questions so far? All right. So what does data management for containers looks like? I've mentioned that we do have support where the users can refer to container images either as Docker or Singularity Hub URLs, or the Docker image is also exported as a tar file and available at a server just like any other input data set. If an image is specified to be residing in a hub, what we do is the image is pulled down as a tar file as part of the data staging job of the workflow. And then we use that exported tar file and we ship it with the workflow and make it available to the jobs as they run. The primary motivation why we want to do that is, our users often run very large workflows with tens of thousands, hundreds of thousands of jobs in there. We don't want to hit Docker or a Singularity Hub for each job, or even more than once. So what we decided to do was we'll piggyback on the data management capabilities of Pegasus for input data sets or your user input files, and use that for our approach in containers, where we just export the container image as a file and then ship it around with the workflow. For people who've been running Pegasus users, they would be aware that everything, all the jobs in Pegasus are launched through a lightweight Pegasus launching executable called Pegasus Kickstart, which gives us provenance information. So Pegasus Kickstart is available as part of the Pegasus worker package. When you are running using your own containers, the Pegasus worker packages are not required to be pre-installed in the container. So Pegasus will automatically figure out if a matching worker package is not installed in the container, then it will be installed at runtime when the container starts on the report node. So the users have options of populating their containers with the Pegasus worker package installed, or they can let it happen at runtime, with the caveat being then for every job a worker package is pulled into the container. So what is our container execution model? Like, you specified your application that you want to run in a container, and now this application has to run on a remote node, for example, on OSG. So the containerized jobs through Pegasus are launched via Pegasus Lite. So Pegasus Lite is a mode where it allows users to run their applications in a non-shared FS deployment where there's no reliance on a shared file system. So if you're running jobs using application containers, then the container image, which we had exported from the hub using as part of the data staging nodes, is put in the job directory along with all the other input data that your job requires. This input data is the input data that you track in the DAX as in the users section for your input files. Then it will load the container if required on the node. For example, in case of Docker, you need to Docker load the container image before you can run the container on that node. And then it will run a script in the container that sets up Pegasus in the container and will launch your user application. Once your user application finishes, the container will be shut down and cleaned up. And then we ship out the output data generated by the application and clean up the job directory. So we are shipping container images around, but we are also taking care that the images get deleted when your job finishes. A thing to note is that a traditional shared FS approach that Pegasus supports does not support containers, because in that particular case we are not launching user executables using Pegasus Lite. We have examples in which you can run your jobs via Pegasus Lite in a shared FS deployment, where you just specify your staging site to be the shared file system on your compute set. If users have questions on how to run containers in a shared FS approach, we can sort of address them, or you can even contact us offline or separately. So what directories are being mounted when a container starts? Like container starts, but then like it needs to get access to the file system on the host node where the input data has been placed. So in case of Pegasus, we took the decision of only mounting the job directory where Pegasus Lite places the inputs. In case of Docker, we mount that as /scratch, and in case of Singularity, it's mounted as /srv. A thing to keep in note is that we do ensure that your user application then gets, when it runs in the container, it is launched in those directories. So Pegasus Lite ensures that the user application is launched in the directory mounted. It's consistent with the Pegasus model of ensuring that whatever directory a user job runs in, the input data will be available for there. So far we haven't seen a need for mounting any other directories or exposing that option for the users. Another thing I wanted to highlight about was the user running in the container. So in case of Singularity, it's pretty simple. Containers are always run in user space. So whatever user your job starts as, that's how your container will be run, and the file permissions are preserved. In case of Docker, it's slightly more complicated, but we try to address it in Pegasus, where like Pegasus, before launching the user application in a Docker container, will create the user in the container that is the same as the user under which the job is launched by the local resource manager on the remote node. So what this ensures is that we are able to stage out the outputs created in the container correctly with the correct UID and masks. And as far as the site admins goes, they don't see files created with any other UID other than the user which the job was launched as. So that sort of brings me towards the end of this presentation, where, for reference, I have included a link to the documentation on the Pegasus website, where you can find more detailed information about our container approach. We also have an example available on GitHub, which will run a montage workflow through Pegasus using montage application container. Any questions so far? All right, so I was, if there are no questions so far, I had planned to show you this example, which I refer to, and illustrate how it can be run. So out here, I'm logged on this workflow submit host. Sorry, I need to switch the sharing. All right. So I just wanted to make sure if my terminal is visible to the users. Like, is the font size good enough? I guess it is, if there are no questions or observations. So right now I'm logged into...
Karen, why don't you make it a little bit bigger?
Is that big enough?
I meant the font size. That's fine.
All right. So right now I'm logged in to a workflow submit node, and where I've cloned the GitHub repo montage workflow v2. So out here, we have a couple of scripts which will create a montage workflow and submit it. We are going to run this example DSS containers.show, which will generate a montage workflow. So the way this example has been set up, even to generate the montage workflow description, we end up running it in a Singularity container. So this portion of the script will just generate a montage workflow for us, the DAX, and that's not required for all user applications, but this is how we've packaged the montage workflow. Then we just have a Pegasus plan invocation, which will plan the workflow and submit it. In my properties file, right now I just I have referenced to just the data catalogs, and we are running this example in the Condor IO configuration, where we will let Condor do the file transfers for us. The montage workflow DAX generator will generate these catalogs. So I will show these catalogs once we've run this script. So the workflow has been planned. I'll submit it for execution. But if we look at, so what does the transformation catalog looks like? So here we have this is the, so referring to a container called Montage of type Singularity, which is published on Singularity Hub at this location. And we've specified an environment profile that needs to be set for the Montage executables to work when your job runs. And then it lists all the transformations or executables required by your workflow and has a reference to the Montage container. So this is indicating that HPX CVT transformation is installed at this location, opt montage bin in the container. And so in this case, like the montage workflow refers to 15 different executables or transformations that the jobs refer to, and we ended up packaging all these executables in a single application. So it's up to the users how they want to do that. All right, let's go into the directory where our workflow is running from. So right now the workflow is already staged in the data. So let's see, I'll probably show some of the input files to I've forgotten this name for the staged, but let's look at an open. So right now I'm showing one, the Pegasus Lite invocation for one of the jobs. So it's an MAD job. So it's a standard Pegasus Lite invocation initially, where Pegasus Lite gets set up on the node where a job is installed, and then it will write out a container launch script which launches your executable. So here, we are launching Pegasus Kickstart, launching via Pegasus Kickstart the MAD executable in the container. And if we look in the .sub file, you will see, since we're using the Condor IO mode, all the transfers are happening using Condor file transfers. So they are referred in the Condor submit file. So you'll see this montage.singularity image that is being transferred via Condor IO with the job. And so here you can see that one of the data staging nodes has pulled in the file. We gave it a LFN name internally as montage.smh, and we are staging it to a staging directory only once. So the file gets exported from, I open this. So the way Pegasus set it up was like from Singularity Hub, we are pulling this to the staging site directory. So this is the directory which the creator job in Pegasus generates. And so the container image is just pulled once, and then we have associated the container in the Condor job descriptions, and it gets transferred. So the purpose of sort of like giving this walkthrough of like, how the container is being transferred and used by Pegasus Lite was just to give users an idea of, what's happening under the hoods. Normally the users will not need to go through the submit directories since, we recommend using Pegasus status and Pegasus analyzer to track your workflow and debug your workflow. Let's see. So we let the workflow run, and while the workflow is running, I will take questions about if people have any questions about what's involved or any clarifications required about the container solution. Okay, so yeah, this workflow will complete. I will also make the slides available and send it to the list. And you're welcome to contact us at pegasus@isi.edu or through our support channels. If you need help or want to talk to us one-to-one about your particular application workflow and how it can be used with Pegasus, or you already have an existing Pegasus workflow and want to package your application in container, we are available. All right. I guess we didn't have any questions. So we'll hang up, and thank you for joining us for our first Pegasus office hours. We have our next Pegasus office hours will be held on Friday, the April 13th. And in that session, we are planning to go over the Jupyter support, which we also introduced in Pegasus 4.8. All right. Thank you very much. Any questions? Last call for questions or clarifications? Okay, great. Thank you for taking the time out to join us for this presentation. Bye-bye.
Thanks, Karen. Bye.